that better? Anyone want to ask a question? Or you're okay, but I could have said that better. Oh, so we tend to think of interest rates like this, right? So if you had a bank account that had P dollars in it today, you get P plus 0.05 P tomorrow, right? You keep your principal, that's where the 1 comes from. Okay. If you do it again for a second year, you'll start at 1.05 P, right? And you're going to get that plus 5% of 1.05 P, and so on. Yeah. What? Well, let's take it the other way. If I put PV in the bank, after 1 year I'd have 1 plus R times PV. After 2 years I'd have 1 plus R squared times PV. After 2 years I'd have 1 plus R to the T power times PV equals FV, right? And so if I just solve it for PV instead of solving it for FV, it's a negative, right? The bank account is this. The bank account is I put in P dollars and at 5%, and after T years, I get some amount out. And this is happening at year T. So suppose instead I knew at year T I'm going to get FV out. How much would I have to have put in today? Right? And 1.05 minus T times FV. So the amount I would have to put in today to have FV out in T years is 1.05 to the minus T times FV. Does that do it? It's a reverse bank account. This last fact you can prove by writing out a pair of series and doing a subtraction, and we'll take it on faith, but you're welcome to go prove it again yourself. The present value of an annual payment starting in 1 year and going forever is the annual payment divided by the interest rate. Okay? You want that proved after class, or go look in the book, but I don't want to take our time to prove it. So let's go back to our energy savings. Interest rate's 5%, and the savings last forever because we're going to make this easy. Then the present value of our savings, remember our savings was like $700 and change. The present value of it is that times 20, or that divided by 0.05, and it's $14K and change. The cost is $4,000. The present net value, right, subtract the two, is 10K. So should you do this? Yes, right? This is a good deal. If they'll let you the money at, if you're borrowing and lending money at 5%, then this is great. But a lot of things could change. I did the math, and you could too, and I'm not interested in doing it on the board. Suppose the savings only last 5 years. Then the present value of the savings is only $3,000. Well, how would I do that if I had to? If I didn't know any formulas, but I did know I had a spreadsheet. Then I would just say, okay, so the savings per year was what, 747? And it starts 1 year from today. And here's the one for 2 years from today, and out to 5 and add them up. So you could just take the present value for each year of the 5 years and add them up and get the present value of 5 years worth of savings. Well, why might something last only 5 years? This is a negative, by the way. Why would something last only 5 years? Is it really going to last only 5 years? What sort of things you buy for your house are really dead in 5 years? There are things. Come on. What dies after 5 years of use? All right, 6, 7 years of use. What? Cars move on to their next owner. What? Which type? Coffee machines. Yeah, they're definitely dead. If you have a lot of people in the house, you'll do in an efficient washer. So, the washers that are front-loading that are efficient. Turns out that run the American way, they last 4 or 5 years, and then like 500 pounds of stuff goes off to the dump. Because you call them up and say, can you fix this? And they say, sure, for $700 I can fix your $500 washer. Do you have any other questions for me? And say, no. In Europe, they last longer. Why? Because the Europeans run them slower. If you put a load of wash in, it'll take 4 hours on the ordinary cycle. Yeah, there's a big difference. Anyway, it's a lot of stuff that dies. But the other answer was in some sense more interesting. How long does an American tend to live in the same place? Not very. So through the beginnings of your college and early work career, 5 years in one place would be a while. This is in one house. You rent an apartment. How long do you think you'll be there? Well, 5 years later, you're going to have a job on the other side of town, the other side of the country, the other side of the world, or you're going to accumulate some money, you're going to buy a nicer place, right? So after 5 years, will you get your money back for some of these things? No, you won't. That's the sad part. If it's an apartment, obviously it's a total loss. You buy a nice refrigerator for an apartment you live in, and then you move to a bigger place. Even though it's a nice refrigerator, you don't want a refrigerator this big anymore. You want one this big. At least that's what I see people buying. So you tend to leave this stuff for things like refrigerators and washers and like. It can be moved, but it's not what tends to happen. Obviously, if it's a rental place, you can't do windows. But even in a place you own, if you do things that people can't see, like in my house, the back walls have a lot of insulation in them. And as a result, the back half of the house is really warm. We use very little heat. But you can't see that. I don't think I will get paid for that when I go to sell the house. So things that are rented, things that wear out, all of those reasons tend to make reality sometimes look a lot more like it's 5 years. Now let's try another possibility. And that is, suppose you have a much higher interest rate. Do you remember Hillary Clinton stumping for president, or is that way too long ago? That's way too long ago. Okay. So eventually she figured out how to run for president. So she started out thinking to run for president by hanging out with your pals from Wellesley and eating cheese and drinking white wine. The problem is there aren't very many votes in that. In fact, there are nearly no votes in that, and those people were going to vote for her anyway. And then she thought a while and went back to her more like Arkansas days and went and found the pantsuits that didn't look great on her and got a pickup truck and drove to the rallies in a pickup truck, stood in the back of a pickup truck, and started asking the crowd things like, okay, who has got the student loan with the highest interest rate? Any of you know? Any of you have student loans, anyone? Come on, 0 student loans in the group? Really? Not a one? Ooh, okay. You know the interest rate on it? Yeah. Well, when Mrs. Clinton started asking these questions, she was getting answers back that were pushing close to 20%. So if your interest rates are through the sky, then 5% is not the problem to you. You could invest in paying off your student loan, or you could invest in an energy-efficient refrigerator, and you can guess what the right answer to that question is. What's the right answer? The student loan, yeah. What about people who maxed out their credit cards? Anyone look at credit card interest rates? Yeah, you're just way too responsible as a group. So go find your friends who went to, like, Cal State Chico and ask them about interest rates on loans, on credit cards. And you'll discover that they can get you for like 20, 25%, plus they know that the people have trouble paying them back. So on top of that, they get like a $25 late fee, predictably every month. The interest rates are fabulous for those people. Well, I'm going to try the same exercise at merely 10%, and you should be able to guess the answer. To begin with, I took 740 and divided by 0.05, which is multiplying by 20. Now I'm going to divide by 0.1, which is multiplying by 10. Is this still going to be a great deal? Nope. Right. And of course, it's not a great deal. So high interest rates will stop you from making these investments. An awful lot of the U.S. population are facing quite high interest rates, either because they're still sitting on student loans or because they borrowed money against their credit cards. And they are just not rationally going to put the money into a project that has a rate of return something between 5 where it paid and 10 where it didn't. That's close enough for them. So it's very rational for that group not to take up energy efficient things. Here I have a much longer time span. I've taken it out to 100 years. I start with a present value of $1,000. And why I'm going out 100 years is not because you're going to buy a washing machine that lasts 100 years. It's because when you talk about climate change, right, you're talking about rather long time periods. We used to think it was 100 years. Today we might not think it's even that long. But let's look and see what happens to damage 100 years out. So here I just multiplied by 1.02, 1.05, and 1.08 to the 100th. And that's how I got the final one. I graphed it all the way in between. At an interest rate of 2%, right, a damage of $1,000 in 100 years' time is worth $200 today. At 5%, I can still see that it's a positive number. It might be a couple of dollars. At 8%, I need a microscope to find it. The rate of return on stocks in the United States has been something on the order of 7. So it really is just a damage problem. And I could do something today that cost $1,000, for argument's sake, and would end up saving the planet a little bit out here. Right? By $1,000 worth of, sorry, put it the other way. If I did something today that caused us in 100 years to have something that saved $1,000 worth of damage from climate change, that would be the same at an 8% interest rate as putting, I don't know, $1, half a dollar, 50 cents in a bank account and letting someone invest it and build some sort of capital equipment or something that I would then get the proceeds from at the end. So high interest rates mean that doing something, and long time spans, mean that doing something today to avoid damage in the future makes almost no sense. So all you're thinking about is climate change will make world GDP go down by, and you can choose a percent, 3%, 5% in 100 years. That's all it's going to do. So it would just be as if every time you bought something, the thing you bought was 5% smaller. Think about it that way. Or everything you bought cost 5% more. That'd be another way to think about it. Your wages stay the same, but everything costs 5% more. That's how they think about economic damages of climate change. If that's the right way to think about it, then stopping climate change and investing in other things are just completely comparable. And all you ask yourself is, will I get a better return in investing in preventing climate change? Let's say, make it tangible. I buy a lot of solar cells today, and that saves me some climate change in 100 years. Is that a better deal than investing in something else today, factory that makes airplanes, and seeing how much money I get in 100 years? Well, what I'm telling you is investing in factories will give you about a 7.5% return. So if all that's going to happen from climate change is you're going to get a tiny little bit of money, maybe you're just better off in forgetting about it and accepting the climate change. Right? That's what will happen if you start thinking about numbers like 8% being right. You'll think other investments are better investments than investments in producing climate change. Do you like that answer? Why? What's wrong with the idea that there are just two goods? There's solar cells that prevent climate change in 100 years, which means that your prices don't go up by 5%, and there's airplane factories that will give you a huge bank account in 100 years such that even with the higher prices, you're better off. That's the story. You don't like it. Why? Well, so you just want me to save the whales. So she wants me to save the whales. Okay, fine. I didn't take account of the whales. You're right. The whales will die. The corals will die. Lots of other things will die. But in our story, all that will happen to us is that things will be 5% more expensive. And that's the way that they tell the climate change story. No, I told the story even more bluntly. I mean, you're still here in 100 years. No more children. You live forever. You're here in 100 years. The consequences, this is, might as well make a theory world utterly ridiculous. Because then we can understand the argument, right? So you're here in 100 years, and the consequences are that everything costs 5% more. That's a statement of how, if you look at the IPCC damages stuff, that's roughly what they say. I mean, they agree that the whales will be gone and all kinds of other stuff. Why? It happens to everybody. No, just talking, the businesses are all gone here. It's just humans. The humans have two choices. The humans can invest in climate change suppression, or they can invest in bigger candy bar factories. And the effect of climate change is that everything will cost, including candy bars, 5% more, and investing in candy bar factories will make everything cost 7% less. Well, in the story it is. Well, what don't you believe? I mean, there's something really wrong, but what don't you believe? Well, but if you read the economic parts of these integrated assessment things, they roughly tell the story I just told you. I mean, not quite so baldly and ridiculously, but they roughly say, and then if you look at the scenarios, then, it's 3 degrees centigrade and 3 degrees centigrade. For each degree centigrade is world GDP goes down by whatever number $1 billion, and I just stated equivalently as prices go up by, some number of percent. Okay? So if you really read it, it's more or less what the assessment stuff says. And I guarantee you my math is right about rates of return. So why don't, what's wrong? There's something wrong here. Something really wrong here. It's not just we killed the whales. Do you really believe that the temperature reliably goes up by 3%? Or by 3 degrees? Do you believe that? What are some of the other outcomes? Like, name another potential outcome. What? Yeah, you get rising sea level. Suppose temperature goes up by 9 degrees. You can't rule that out, can you? So the interest rate story gives you one answer, but what's missing here is the part about the damage is really funny. The part about the damage says we'll have a little change in the climate and a little change in the economy because of it. It doesn't say that's one scenario. There are like 20 scenarios here. We don't know which one of them will show up right, but we do know that some of these other scenarios look like a planet fire where it all gets burned down. That's what's wrong with the diagram and the argument. It's not that the numbers are wrong. It's that the conception of climate change as, for sure, it's only 1 meter of sea level and 3 degrees. That's what's wrong in the argument. All right, we will continue with our stuff, and please do pull out the homework and start it.